Okay, now we've reviewed multiplying fractions and dividing fractions. So now it's time to review adding and subtracting. Your rules for adding and subtracting fractions are very clear. In order to add them, and then subtract will be the same way, which we'll show in just a minute, the key is that we have to have the same denominator. As long as the denominator is the same, then we just simply add the numerators together and we keep that same denominator. So basically what we're saying is if we have 1/3 plus 1/3, I mean, if you think about it, if you have 1/3 of a pie plus 1/3 of a pie, together now you have 2/3 of a pie. So that's all we did. We kept the same denominator and we just simply added the numerators. When we talk about subtracting, it's really the exact same thing. As long as the denominator is the same, we just simply subtract the numerators and keep the denominator. Now the problem comes in when we don't have the same denominator, because that's our rules. So we have to then sometimes get a common denominator or the same denominator. All right, let's look at a couple of examples and we'll work our way through it here. This one says we have 1/9 plus 5/9. Now, the key here is, are our denominators the same? And they are. So that means we can just use our rule. And the rule says we add the numerators, so that would be 1 plus 5, which is 6, and we keep the same denominator. So our answer would be 6/9. But we're not done, because we never ever leave fractions in a not reduced state. Because these have a common factor, we have to reduce it down. 3 will go into 6 2 times, and 3 will go into 9 3 times. So our final answer has to be 2/3. Anything other than that is not proper. Okay. So if we're adding or we're subtracting, as long as we have the same denominator, it's not a big deal. In fact, let me move to, I don't have an example of subtracting, do I? I should have done that. As long as the denominator is the same, we just work with the numerators and it's not a problem. The problem comes in when we're adding things that don't have the same denominator. And in this case, now we have to get one. So just to refresh your memory, we have to figure out what would be the common denominator, or what can we use that 30 will go into and 45 will go into also. So we start thinking about our multiples. I usually start with the largest number, 45. 45 times 1 is 45. 30 will not go into that. 45 times 2 is 90. 30 will go into that. That tells us that 90 is our common denominator. Now, in order to create equivalent fractions, which is what we have to do, we have to, hopefully everybody remembers this, we have to figure out what do we multiply 30 by in order to get 90, and that would be a 3. We do the exact same thing to the numerator to keep it balanced. So 3 times 7 would be 21, and then we move to the next fraction. What do we multiply 45 by in order to get 90? And that would be a 2. So we have to do the exact same thing to the top to keep it balanced. 2 times 2 would be 4. Now our denominators are the same, so we can keep that denominator of 90, and we can just work with the numerators. 21 plus 4 would be 25. So this is our answer, but now we have to always make sure that it's in fully reduced form. And there is something that will go into 25 that will also go into 90, and that's a 5. 5 goes into 25 5 times, and 5 will go into 90 18 times. So our final answer here is 5/18.